I'm Nick Hake, and I'm sitting here on our new Seaward 46102, and with me is John Zeitlin, who supplies a product to us that we're very excited about, and it is a 12-volt generator as opposed to a 120-volt generator that we've installed on many boats in the past. And it's actually, in my eyes, almost unbelievable what the difference is and what this can do, as opposed to a 120-volt AC generator. So I learned a lot about it in the installation of this generator and the 2-volt batteries that we use, but I'm not all the way there on the knowledge of it, but of course John is, so he's going to take some time to get down to the nitty-gritty on what it is exactly that we've done with this boat and why it's so darn good.
Well, thank you for inviting me down to talk about this, Nick. And it basically comes down to fundamental philosophies on how to charge and run electricity. It's all about power and what's the most efficient ways of doing it. And you hit on the highlights. You're talking about DC, whether it's 12, 24, whatever voltage DC, versus using alternating current. Mm-hmm. And some people don't realize way back when Thomas Edison wired all of Manhattan DC. And the only problem with DC was when he tried to go beyond Manhattan, beyond the 2 miles, the wires had to be really big in order to carry the current and things like that. And that's where the real advantage of alternating current is. But on a boat, not 2 miles long, so you don't have those kinds of problems. And really, it's like a lot of things, the answers are usually somewhere in the middle or a blend of things. But when it comes to a boat, if you have DC, the advantage and the efficiency starts going through the roof. I've been meaning to do this for many, many years, and finally did it. And DC, it comes down to fun on how you operate the boat. Because so many people use, when they use an alternating current, that anytime they use anything that requires alternating current, whether it's the microwave, the hair dryer, the air conditioning, they've got to start that generator. Whereas if you use DC as the main background on a boat, everything's running off the batteries. Now people think, well, 12 volts, I don't have my 120 volts from my hair dryer, microwave, or air conditioning. You still do. You have the inverter. So you size the inverter to the battery bank in which your loads are, and so you're not trading off one or the other. You actually have everything. And because you have DC as the background, anytime you're running anything, you don't have to start an engine. So you run everything off the batteries all the time. And then the only time you start the engine is when the batteries need to get charged.
And this is where you're getting into the really fascinating part of it. Just to cut in for a minute, my wife is used to air conditioning. She likes air conditioning on boats that we've had in various places. And you can't really start that air conditioner without the generator running. And therefore, we wound up putting an incredible amount of hours on the generator on those boats, and an incredible amount of maintenance. And I learned very quickly that a generator requires maintenance too, but it's pretty much proportional to the amount of time you put on the generator. And we have discovered with this boat that running the generator in a range of approximately 2 hours per day, as opposed to all day long, as we did in the past, 2 hours per day, we charge the batteries and we can run off of the inverter, batteries and the inverter for at least 24 hours, air conditioning running and all the normal stuff that my wife likes to use on a boat. It's incredible.
Yeah, it's one of the... I always try to put something that people can relate to so they can understand, like especially at boat shows, things like that, so you can communicate this. And the easiest one I found is like try to explain air conditioning. And so many people say you can't run the air conditioner off the batteries, but you can. It's a real fact. As long as everything's properly sized, it's never a problem. And if we use that example, like if you're going to run the air conditioner all night, say you're at 10 hours, you have that engine running for 10 hours, an AC genset engine. That whole 10 hours is burning fuel, making noise, pollution, and the biggest thing most people don't even think of is you're putting your life at risk, because typically people are not watching that engine. So anytime you're on a boat, you have an engine running, it needs to be monitored. It's not that you got to stare at it the whole time, but you need to check it. And everyone always thinks of carbon monoxide. The big thing you have to watch out for is fire. And scenarios happened to me twice where basically you put your life in jeopardy. And it's never something you think of. I had a case where a water pump went out. It's not the actual engine, but if you don't have any cooling water, eventually it boiled all the water out of the heat exchanger, it caused a problem, and could have started a fire if we didn't catch it in time. So getting back to the thing about the efficiency, so now that whole 10 hours you've been running an AC genset, burning all that fuel, whereas if you do it with the DC backbone, you run off the batteries and everything's properly sized, it runs just fine. You get up in the morning and literally in about an hour or less, if the battery's even needed, if you have a smaller battery bank, larger one you may not even need to do anything, you just start your engine up. If you're going to motor, that will charge the batteries up, and if you're going to be there for a while, use the battery bank, the genset to charge the battery bank up. In about an hour, you're all charged back up. So now you're talking 10 hours of runtime versus 1 hour of runtime. So there's a 10-to-1 right there. On top of that, your typical AC genset is so much larger with a bigger engine. The fuel consumption is 4-to-1 compared to this DC genset with a smaller engine. So now you're at 40-1 ratio on efficiency. And on top of that, the DC genset that I designed has a throttle. So as you charge, you can actually reduce the RPM and save more fuel and even less noise. Whereas an AC genset has to run at full RPM all the time or it won't work. Because an AC genset has to have the 60 hertz frequency. And if you change the RPM, that changes. So it won't work except at full output, whether you're using 1 amp or 100 or whatever many amps. So there's more efficiency. When you get all done, it's almost like a 100-to-1 ratio of runtime and fuel burn of an AC genset versus DC genset. You just have to get used to running everything off the batteries all the time. And once you do that, it just works. You know, people, you see it all the time. Why didn't someone think of this sooner? It's always been out there. They've just always done it this way for years and years and years. Like I said, I've been meaning to do it for many years at the boat show, and one day I just said, I'm not waiting any longer. I'm just going to do it because it just makes sense when you look at the numbers.
And again, you save fuel, but in our case, fuel is not really that important to us. But we did realize that we spent, it's not the cost of the fuel, it's the trips to fill the tank up. And seriously, with this 12-volt system, it uses so little fuel, it's insignificant as compared to, say, just motoring the boat around. It's such a low percentage, whereas prior to that, when we were using 120-volt generators, it was a significant amount. And even though the cost of the fuel is not that painful, the cost of maintaining the generator and the time that it takes to go fill up the tank and all that, it mattered to us.
You know, on the price of fuel, it actually has gotten to the point, because in the old days where it was $1 a gallon or less for diesel, it wasn't as significant. But nowadays, with diesel being 4, 5, 6 and more as you're traveling, if you took at the hours of runtime AC versus DC, you will find out that doing an AC genset, you can actually take a fully paid AC genset, throw it away and put it in a DC, and just on the fuel savings, I ever hate to use price as a reason to do something. It's always like it doing the right way, the most efficiently, the most economical. But just on price alone, it makes sense. It's going to save a boat owner so much money every year just in operating costs. Just at $6 a gallon, it doesn't take many hours of running before you're into 4 and 5 figures of fuel.
And that doesn't include the maintenance.
Right, not even including the
amortization of the engine over a period of time.
I had a customer just got back from the Bahamas, and he was cruising for 6 months. And that genset, the same one that you have on this boat, was his main source of power. And he only had to run it about 120 hours for the entire 6 months. He never ever plugged into a marina, not once. I told him that was a little bit, he needs to do it once every 3 months just to top, because batteries need to go through the full cycle. You don't ever want to do it off the genset because it doesn't make financial sense in terms of running it for 20, because to do the full charge on a battery bank takes anywhere from 6 to 36 hours, because it's a chemical process, and it's got to move the electrons on and off the sulfur, on and off the plates. So about I suggest once a month if you have a marina at your access, if you're out cruising, certainly at least every 3 months, plug in the shore power and let the shore power go through the complete cycle to bring it back to that full 100%. Because when you're out cruising, you're basically using 1/3 of the battery bank. You're using down to that 50% and back up to the 80%, 85%, because it goes pretty quick, whether it's off the generator or the engine, whatever you're doing. That last 15%, that's critical for the long-term, how long the batteries will last and everything else. It's necessary to do that once in a while. But that last 15% can take many, many hours. It's sort of like the fine-tuning.
Sure.
So that's where you plug into a marina, like say once a month. Or
one thing that I remember discussing with you, this boat has 6 2-volt batteries, which is ideal. A boat, if you can do it with 6-volt batteries, right? But or you can do it with 12-volt batteries. But what is the critical? Why would you use in your words, explain why you would use a priority 2-volt battery, or if you had, or a 6-volt, and then if you absolutely had to a 12-volt? Why the difference?
The difference comes down to, this is something I learned from people in the solar industry, because they have these big solar panels, like they're doing large complexes, and they have some of them have hundreds of these 2-volt batteries that they use. And it has to do, again, going back to the chemistry and the physics of how the power. And power is electrons moving. And anytime they move freely, you get the most efficiency. With the 2-volt batteries, and say you have a 12-volt system on a boat, you're going to need 6 of the 2-volt batteries put together in series. By doing that, the voltage gets added up each time, and the amperage stays the same. So if you have a 1200 amp hour 2-volt battery, you put 6 of them in series, you still have 1200 amp hours, but now you have 12 volts. And because they're wired in series, the way the wires are, it's going to force the electrons to move through every cell of every battery. And that ensures the longest life cycle of the batteries. Whereas if you take batteries, say a 12-volt battery, you can get 4 of them in parallel, so now you have the same amp hours and same voltage. But because they're in parallel, even if they're wired correct, which a lot of boats are not, what typically tends to happen is the electrons will go in the first battery and come out the 4th one and skip 2 and 3. By doing that, you're not going to get the full life cycle out of the batteries. Of course, you can just move the batteries around every few months, but that's a lot of work. So to eliminate that, you just put them in series, and it forces the current and the electrons to go through every battery, and that's the most ideal way of doing things.
Does it also give you a faster charge? The actual batteries will charge up faster with more amperage or more capacity?
What gives you the faster charging is the fact that if you use, say, absorbed glass mat batteries, which those lifelines I recommend are, that gives you the fastest charging. Whether series or parallel doesn't really matter. But because they're in series and they're AGMs, whatever you can give them, they will absorb. And
okay. The same with when you're using the batteries. Does the fact that there's 2 volts in series, do you get more efficient use of the power coming out of the batteries, or will it? Basically, the same question that I had with charging the batteries. You know, you explained that the 2-volt batteries charge better, more evenly, faster. Do they discharge the same way?
Well, what's going to happen is they will discharge exactly the same. Because they're in series, you're going to discharge all 6 batteries at the same time, as opposed to favoring just, say, 2 on the outside versus the inside. In the case where people typically have, say, the parallel wired wrong, where they're going to have the red wire and the black wire going to one battery, and then all the other batteries in parallel, what they're really doing is they're just using one battery in their whole circuit. And what's happening is that battery draws down, the other batteries are sort of recharging it, which is not a real good way to do it. When it's done right, whether it's the red or black would be at the other end. But even then, what happens is the 2 batteries on the outside are being used, and then the ones on the inside tend to recharge that guy. So in terms of efficiency, and whether it's life of the batteries or just overall better way of doing it with the 2 volts, it's spreading out so that the load is evenly distributed. And it's just a more ideal way of doing it, whether it's charging or discharging.
Now, we are taking this 12 volts and we're using it to create 120 volts AC via an inverter. I noticed that there is a large price difference in inverters. You can buy a 5,000 watt inverter for $300, or you can spend easily $3,000 on an inverter. What do we need? I mean, what do we need to consider when we're installing an inverter?
Back years ago when I first started, they used to buy these combination inverter chargers that were in those multiple four-figure price ranges. And that's just what was around, that's what everyone did. And like everything else I do, I try to take the blinders off and just look at the physics, because there's no arguing then. And what I found is you're better off getting freestanding inverters that you can get for a few $100s. And I tend to get the bigger 5 kW inverters that would normally go in a boat that had, say, the 3 kW inverter chargers, because for the price difference and everything, plus the fact that it's a 5 kW, has all kinds of overload protection built into it you're never even going to use. Because when we're running the air conditioner off the batteries, we're in the anywhere from the 1,000 to 2,000 watt scenario. So you're never ever pushing that inverter to produce the loads that you need.
Right.
So you're going to get a failure mode and everything else just exceeds that smaller inverter charger. And then you can buy a standalone, say 60 amp charger for doing your shore power charging, because you have plenty of time. You don't need to do it literally in 1 hour to charge it. You have the time and luxury to charge it and 60 amps is fine.
Okay, interesting. Break. Okay, I know because I built the boat and helped install the batteries. They're big, heavy batteries, 100-pound batteries. The 1,200 amp hour 2-volt batteries, 6 of them. So we have, as you just explained earlier, 1,200 amp hours at 12 volts. So what can we, on a boat like this, we have a voluminous interior, a lot of electrical needs. We have a freezer, a refrigerator freezer, an ice cube maker, and air conditioning and everything. Tell me what we can expect by the numbers.
Well, the numbers are pretty straightforward. Refrigerators, the real key on refrigeration, freezer, all that kind of stuff, comes down to insulation, because the basic machinery is all about the same as far as the efficiency. And so when you get into the efficiency of the insulation, you're going to consume anywhere between 30 amp hours up to 75. I've seen cases where it's really bad, 100 amp hours a day for refrigeration in a 24-hour period. Typically, it's around 50 to 60 amp hours a day. And then, whether it's your lights or whatever else you're doing, for your average cruiser, you're talking a 24-hour period, maybe 100 amp hours for all that stuff in a given 24-hour period. When we get into air conditioning that has a specific amount of consumption, what's nice is the new air conditioners like you have in here that Cruise Air makes. It's one of the few times where I've seen big companies actually truly improve their product. They reduced the electric consumption by at least 20%, and the output of the cold air with the new fans and everything 2 or 3 times, 200 or 300%. So I know you have lots of air conditioning in the boat, and when you're connected to shore power, it's not a problem. But you can actually run all of that off your inverter and your battery, because you have ones big enough to do it. A lot of other boats that, whether it's small, let's say your typical 16,000 BTU air conditioner, that consumes, the new one, it's around 10.5 full load amps. And that means the compressor's on, the blowers are blowing, everything's running at full output, which is not all the time. That's just on first startup. When I've gone out cruising here in Florida, you're out in the sun all day, the whole boat is like a heat sink, and it may get up to like 95 degrees inside the boat. And I've turned on a single 16,000 BTU, and it took a full hour to bring that boat into the 70s, because it is so much heat that's been trapped in the boat all day. You got to get rid of that first. So that first thing is an hour of consumption at full load. And so that would be about 100, 105 amp hours for that first hour. And then what happens is now it's at that point, the next run time, it's turning on and off. The fan may be running or not running, the compressor turns on and off, and the consumption of the next 7 hours is about the same as that first hour. So basically you're doubled whatever that draw was that first hour. So in the case of 16,000 BTU at 104 amp hours, you now consumed 208 amp hours of power. And with that 1/3 rule on batteries, if you basically triple that, because you have the 35% consumption, that
the 1/3 rule, as I understand it, is that we do have 1,200 amp hours, but we don't use 1,200 amp hours. We only drain the batteries down approximately 1/3.
Well, actually, you bring it down to, say, the 50%.
50%.
But when you charge back, if you remember from the earlier conversation, you can't do that last. It doesn't make sense economically to do it off the generator, the engine, until you plug in shore power. So you have the ability to charge back up to 85% from the 50. So that's 35%. So that's where that 1/3 rolls.
Okay.
So that's how much you have available to actually use on the boat.
And on this boat, that would be how many amp hours?
So you have 1,200 amp hours. 1/3 is 400.
So, okay.
That's what you have. So in that case there, we've consumed, in that whole period, around that 16,000, only 200 amp hours. So you've only used half of what you have available to even do. So you may get in the morning, not even have to start the genset.
Right.
But if you're running other stuff to it and you get low and you want to, start it up and the genset will charge it back up in about an hour, as opposed to having to run an AC genset all night long and noise, fire, or everything else we talked about.
Yep, that's fair.
So, and then if you have the 10,000 BTU on, its consumption, if I remember right, is somewhere around 60 or 80 amp hours, and the 6,000 BTU is even less.
Right.
So depends which one you have on, you just add up the numbers and there it is. Basically take the amount of amp hours you're consuming and triple that, and that's the size of the battery bank that you need, because that's what you have available to you. As you're out cruising, you have basically 1/3 the rating of the battery bank as what's available to use before you have to recharge.
Great.
And so if you have a load monitoring system in your boat, you just look at it when you see the voltage where it is, and just by turning the generator on and running it as you need it, you keep everything in sync. And it's just like a fuel gauge in a car. It's that simple. It's a different way of looking at it in terms of consumption versus having to have it on 100% of the time, no matter whether you need this much or all of it.
Great. John, thank you very much for giving myself and our customers here an education on a 12-volt system. And maybe we'll need to talk to you again sometime in the future for a little more detail.
Sure.
Good.
Thank you very much for having me down, and thank you for having the insight and to look at all this and be open to it, because really it's like pulling the rug out of people. They're so used to doing a certain way because that's what we've done for years. But when you look at the numbers, it just doesn't really make sense.
Well, you did get some resistance from me up front because I thought there was a price to pay for everything.
Right.
But nothing is for free. But this is close to free as you can get.
It is free when you compare it to doing it as an AC genset.
Exactly.
But I mean, there's costs associated with it, but it's so much more economical and more efficient than doing it the other way. It just makes, like I said, I've been planning on doing it for 15 years. And about 3 years ago, I was up at the Annapolis Boat Show and I said, no more. I'm not putting this off any longer. And I spent every minute of every day between the Annapolis and the Miami show coming through all the various prototypes, making sure that it's done correctly, not just having some wannabe product out there, so that it can be reliable.
Okay. Thank you.
Yeah, pleasure.